Good day, everyone. We are here to present our topic titled Understanding Data Structures and Algorithms in Software Development, focusing on the stack data structure. In this presentation, we aim to define data structures and algorithms, explain how stacks work, and discuss why these concepts are important in software development and information technology. So what is data structure? A data structure is a way of organizing and storing data in a computer so that it can be accessed and used efficiently. Instead of storing data randomly, data structures help programs work faster and more effectively, especially when handling large amounts of information. Examples of data structures. Some common examples of data structures include arrays, stacks, queues, and trees. Each data structure has a specific purpose depending on how data needs to be stored and accessed. In this presentation, we will focus on the stack data structure.
An algorithm is a step-by-step instruction used to solve a problem or perform a task. In computer science, algorithms tell the computer what to do and in what order. They are not limited to programming. Use algorithm in daily life without realizing it. For example, following a recipe, then brushing your teeth, all follow a fixed sequence of steps. So there are real-life algorithm examples. Let's take a sample of making tea. First, boil water. Second, add the tea leaves or a tea bag. Third, add sugar and milk as needed. Fourth, let it boil for a few minutes. Finally, pour the tea into cup. Each step must be followed in order to get the desired result. This sample process is an algorithm because it has different steps, a sequence, and a final output. Relationship, data structure, and algorithm. Data structure and algorithms work together. A data structure is a way to store and organize data, while an algorithm is used to process that data. For example, if data is stored in an array, we use searching or sorting algorithm to work with it. Choosing a right data structure helps an algorithm run faster and more efficiently. In short, data structures store data and algorithms manipulate into solve problem efficiently.
A stack is a data structure that follows the rule LIFO, which means last in, first out. This means the most recent item added to the stack is always the first one to be removed. A stack recognizes data in a vertical order, and we only access the element at the top, called the top of the stack. Stacks are used in many computer processes such as undo operation, browser history, and function calls. They are important because they help computers handle tasks in a clear and organized way, focusing on the most recent action first. And next is the real-life analogy or plates. And to understand stack better, think of stack plates. When you add a plate, you place it on the top. When you take a plate, you also take the one from the top. You never take a plate from the middle or bottom because it would collapse the whole stack. So this is the same way of stack works in computing. And the last plate you put is the first plate you remove. And this real life example makes the LIFO concept easy to visualize and remember. And next is stack operations, push and pop. A stack has two main operations, push and pop. Push means adding an item to the top of the stack, just like placing a new plate on the top of a pile. Pop means removing the item from the top of the stack. You can only push and pop from the top, never from the middle or bottom. If the stack is full and you try to push it, it's called overflow. If the stack is empty and you try to pop it, called underflow. These operations make stacks simple and predictable and easy to manage.
Importance of data structures and algorithm in a software development. Data structures and algorithm are very important in a software development. Data structures help us store and organize data so it can be used easily. Algorithms are step-by-step method used to solve problems. Learning DSA help developer write fast and efficient program. Good algorithms are save time and memory, which is important when working with a large amount of data or real-time system. DSA also improve problem-solving skills and help developers choose the most suitable approach for a given problem. Stack in software development application. A stack is a method of storing and managing data where the last item added is the first one removed. It works like a pile of books. When you add a book, it goes on top, and when you take one away, you remove the top book first. In real software application, stacks are used to keep track of tasks and actions so the most recent one is handled before earlier ones. Example, function call in program where each running function is placed on the stack. Undo and redo action in the text editors. Back button in web browser to return to the last visited page. Conclusion: data structure and algorithm are essential components of software development. They enable developers to design efficient and reliable applications. Among various data structures, stacks play a crucial role in managing execution flow, memory, and user interaction. A strong understanding of DSA not only improves coding efficiency but also enhances logical thinking and problem-solving abilities, making it vital skills for every software developer. That's all. Thank you for listening.